I'm now going to present to you the operation of the Ventway Sparrow miniature turbine ventilator made by Innovitec. I'm going to start by explaining to you how the ventilator is connected both to electricity and oxygen. Firstly, with all ventilators in the world, you have to decide where is the electrical power source coming from. The ventilator has a place to plug in the electricity at the back, add a battery pack which is either fully charged giving you 4 hours or will be charged by the electrical input. Secondly, you have to provide oxygen supply to the ventilators. You do not need a pressure source for air for this ventilator because it has a turbine. You need only an oxygen supply source, which can come either from a valve connected to a pressure source by a disc cable, and you can control the oxygen concentration, or you can add this very cleverly designed oxygen concentrating device which allows oxygen to flow into it and then collects the oxygen, so when it goes into the oxygen input at the back, you can provide 1 or 2 liters a minute to give you 30-40% oxygen according to the minute ventilation the patient is getting. Similarly, if you're in the hospital or emergency room and you have pressurized oxygen, you can put the demand valve into the same opening and it can be connected very securely. Starting the machine, it has a very good graphic user interface. The first screen, and I will turn it on now by pushing the start button, the computer will boot up and you will see that the first screen that appears is the logo, allows you to identify whether the display is working properly. To navigate the graphic user interface, there's a control knob here which you turn and click to identify the item that you want. The first thing that will come up after the logo is a circuit verification test. To do the circuit verification test, you have to have the ventilator circuit plugged into the right place, and they can only go in one way. There's a flat end and a round end. It can only go in one way, okay? And if you look at the PowerPoint presentation, you will see what will appear on the screen. It says disconnect the patient and the oxygen, so you have to disconnect the patient and the filter and the oxygen and everything else, and you only have the ventilator circuit in place, and the machine will now do a circuit verification test to see that everything is in the right place and the circuit is working properly. And it will do it in 12 seconds, and you will watch it being done, and in 12 seconds you'll be able to move to the following position. I just want you to recognize that if the circuit verification test fails, there are a few obvious reasons. One, you have not disconnected the oxygen demand valve if it's in place, or the oxygen reservoir with the low flow oxygen must be disconnected. The filter must be disconnected at the time of the patient, and any filters or dirty obstructed inlet filters, because sometimes we put a filter in a dusty environment like in the field at the input at the back, must be removed for the circuit verification test. The reason that these filters can have a little bit of resistance, and the machine recognizes that and says that the circuit is not intact. So make sure the circuit and tubes are connected properly. There's no kinks and disconnections or tube rupture or injury to the tubes, and there's no filters or HME connected. So once you see on the screen the sign, you simply click on the button, and in 12 seconds it will go through the process and do the circuit verification test. Then the ventilator is ready for use. The first thing you have to select is whether you want an adult or pediatric ventilator. It automatically starts with adult, and all you have to do is click on the button and it will change to adult. It then gives you the option to select the patient's weight, because the ventilator has built-in parameters limiting the parameters for children and for adults. After you've selected the weight, and in this case with this size lung I'm selecting 60 kilograms, you then have to say which ventilatory mode you want. And in this example, as you can see, I've selected SIMV with pressure support. In this case, I will select invasive ventilation. The ventilator is now ventilating the patient at the predetermined parameters. I want just at this moment to draw your attention to a few things. One, you may get such a display which says warning, change to a new patient. There are indications on the screen if the patient coughs, a red C, if the patient triggers the ventilator, and I'm going to demonstrate that now, or if the pressure sensors are being zeroed. You will notice on the graphic user interface, at the top, a little bit to the left of middle, you will see a little red box, and if the patient coughs, you will see a C, and maybe, as happened, a high pressure alarm. If the patient triggers the ventilator and takes a few breaths like the patient is triggering now, you will see a red indicator with a T showing you the patient triggered every breath. If you see a Z, it means that the pressure sensors are currently being zeroed, and the only relevance is that on the graphic screen you will see crossed arrows saying that it's not recording at this time. There is a quick start option on the Ventway Sparrow where all you have to do is enter the patient's weight and push the quick start double arrow to the right, and then once you've selected the weight, you have to select which ventilatory mode you want, as we did before, whether invasive or non-invasive. Connect the patient and press OK. You will see on the screen now the ventilator parameters display. You will see the breaths per minute rate, which is preset by the default in the ventilator, the selected tidal volume, which will be the tidal volume in mandatory ventilation, and if the patient takes a spontaneous breath, what the tidal volume is in spontaneous ventilation, and you will see the resultant calculation of the delivered minute ventilation. If you as a physician select to increase or decrease the breaths per minute, you have to move the cursor to the breaths per minute, click on it, and then adjust the breaths per minute each way you want. I will go up to 14 breaths a minute. Similarly, you can change the tidal volume. At the moment it's 360. I'm going to make it 380. In the display of the ventilator parameters while the ventilator is working, you will see that the breaths per minute are as 12 on the screen, and I've selected 14, and in parenthesis is actually what is delivered to the patient. This is SIMV, and he may take more breaths or less breaths, so there's the set and what's actually getting to the patient. If the patient is non-invasively ventilated via face mask, the ventilator is programmed, when you select non-invasive, to compensate for the loss of volume due to leaks from the face mask or laryngeal mask airway. Even if the endotracheal tube does not have a balloon and you select non-invasive, it will adequately compensate for the leak, making it ideal for ventilating patients who want to talk during ventilation, or for children in which you do not use a balloon. If you move the cursor onto the graphic indication and you click on it, you will immediately see the pressure or flow graph coming up. And you can change it from pressure to flow, and you can see the graphs. If the sensor is being zeroed, you will see lines which indicate that the graph is not working. To go back to the main menu, you just hit the return and you get back to the pressure monitoring. When you move the cursor to main menu and select the main menu, you have the option to start or stop the ventilator, to enter a new patient, to change the ventilator parameters, to set the alarm settings, and then there are some advanced settings. Remember that if you push new patient, you will stop or start the ventilator. It will give you the option to confirm it, because it's a dangerous selection. You'll have to confirm it twice, and the ventilator will stop for the new patient or reset. The ventilator parameter screen allows you to select the type of ventilation and also the pressure support you wish, and other parameters. In the advanced settings main menu, it will allow you to load the default settings of alarms and parameters. It will allow you to adjust the brightness of the screen. It will allow you to select a language. At least 10 different languages are available on the Ventway Sparrow. And it will allow you to select the volume of the alarm systems. When you select in the advanced settings the technical mode, it gives you the option to adjust many parameters of the ventilator in terms of setting the time and date, as you would do on any computer or mobile phone. It tells you the working hours of the ventilator, and if you want to change the screen to the next screen in the technical mode, you will see in the bottom left-hand corner the indicator to go down to the next screen. If you selected logbook, it will give you the indication of the alarms that occurred and the user interaction with the ventilator that occurred. This is all recorded and can be downloaded by USB to a computer for evaluation. I want now to address the use of the Ventway Sparrow MRI approved ventilator, identified by its blue color, in the MRI scanner. Note, the Ventway Sparrow models, the 100MR and 900MR, are designed for use in the MRI scan to ventilate the patient in the vicinity of the scanner, shielded, and can be used at a magnetic field strength of 47 MT and 470 G without creating any MR image interference. Note the MR indicates that it's magnetic resonance approved, so the 100MR and the 900MR may be safely used in the MRI environment up to 3 Tesla. Failure to attend to this limitation may result in injury. Note that if the MR is not depicted on the model, it cannot safely or legally be used in the MRI environment and has not been tested. In the MRI environment, the use of the ventilator must be safe and secure. The ventilator should not move or fall or be pulled when the patient is moved. It must be safely secured using a 1/4 inch stainless steel button head socket cap, bolt screws, and an Allen hex drive. Choose an appropriate screw length that ensures that between 6 to 8 millimeters of the screw are fastened inside the ventilator. So to attach the ventilator to the shelf or table in the MRI environment, you must drill the required screw hole 7 millimeters in diameter into the surface on which it's going to be mounted. Insert and tighten the screws as described on the previous slide, and ensure that 6 to 8 millimeters of each screw extends into the ventilator to keep it secure. Pull up gently on the ventilator to ensure it is properly secured. Thank you very much.